Hey guys, so we're going to go over the final page in our Chapter 12 Solutions and Molarity Notes. And with this, we're going to be bridging the gap between solutions and molarity, stoichiometry, and chemical reactions. So we're bringing really all the last three chapters together. So here's the question I want you to think about. Think way back to the demonstration at the beginning of Chapter 8 when I made pure elemental silver by putting copper wire in an aqueous solution of silver nitrate. I want you to think about how many moles of silver nitrate did we use, and was it in excess, or what did we actually run out of first? If you remember, the silver nitrate was clear and colorless, the copper wire was copper colored, and at first it turned black and then turned white silvery, and the solution went from clear to blue when we were done, because copper nitrate is going to be blue in color. And when I was finished, there was some copper wire left over. So just from our observations, if there was copper left over, what did I run out of first? I ran out of the silver nitrate first. Okay, so we're going to start this with a molarity problem. The silver nitrate that I was using was 0.100 molar, and I used about 100 mils of it. Now, when I made it, I actually made a liter, but I used just about 100 milliliters. I kind of just poured it into the beaker. Here I've got 3 sig figs. Here I only have 1, but for the sake of this, we'll keep maybe 3 throughout the problem around at the end when we're done. You know that your molarity equation is molarity is equal to the number of moles n over liters. So let's fill out that equation. I want you to make sure you stop and check your calculator and make sure you get the same answers that I do. So please pause the video and check each step of the problem. So we have 0.1 molar is equal to n over 0.1 liters. We want to isolate and solve for n. So n is going to be equal to 0.10 molar, which is moles per liter, times 0.1 liters. Now, how did I get 0.1 liters? I converted my 100 milliliters up here. So N is going to be 0.01 moles of silver nitrate. Now that I've got moles, I can plug that into my BCA table. This is an important step I want you to be comfortable with. If you are given molarity in liters, you can find number of moles. Okay, so let's say I use 2.17 grams of copper wire. I need to convert that into moles in order to fill out my BCA table. So I'm going to take my 2.17 grams and do some dimensional analysis to get to moles. From the periodic table, I know that every mole of copper has a mass of exactly 63.55 grams. When you divide that, you're going to get 0.0341 moles. Now I'm choosing to keep 3 sig figs here until I'm done. So I have 3 sig figs here. I have 3 sig figs here. Now here there's only 1, but we're not going to worry about that right now. So first step, you have to write and balance your equation. So we have 1 copper plus 2 silver nitrate plus 2 silver gives me 1 copper nitrate. So let's look at what we started with. Before the reaction starts, I know that I have 0.0341 moles of copper. That's from my dimensional analysis. And I have 0.01 moles of silver nitrate. Now where did I get that from? That was my molarity equation up here when I solved for n number of moles. Before the reaction starts, do I have any products? Nope, those are zeros. So look at your ratios and look at the amount you have. What is going to run out first? In this reaction, I need twice as much silver nitrate as copper. And if you look, I have a lot less silver nitrate than copper. So what must I run out of first? It must be the silver nitrate. So I want you to focus right here. We're going to use up all of that silver nitrate, and none of it will be left over. For the copper, I'm going to use up 0.01, that number comes from my moles of silver nitrate, times the mole ratio, which is unknown over known. So I'm trying to solve for how much copper, unknown, over 2, my silver nitrate, that's my known quantity. So this is going to be 0.01 times a half, which is 0.005, so 0.0341 minus 0.005 is 0.0291 moles of copper left over. So this is in excess. And that makes sense with my observations because you saw that there was still a copper wire left over. So how much silver did I create? Take that 0.01 times the mole ratio, 2 over 2. I created 0.01 moles of silver. And how much copper nitrate did I produce? That is the stuff that is blue in solution. 0.01 times 1 over 2, 0.005 moles of copper nitrate was created. And there is excess copper left over. All of the silver nitrate is used up. So how many moles of silver nitrate did I need? Well, I needed a lot more than the 0.01 that I had to completely react all that copper. So I only have the 0.01. That means some of the copper will be left unreacted. So was silver nitrate in excess? No, it was limiting. It ran out first. It was my limiting reactant. So I'm going to box this in, put a star, and label it LR. It is what I ran out of, and it is what everything else on the periodic table was based off of. Or BCA table, not periodic table. Okay, so the next question. How did I make that 1 liter solution of 0.1 molar silver nitrate? So if molarity is N over L, and I needed 0.100 molar in a liter, I'm solving for N. N is 0.100 moles. Now, before, I only used 100 milliliters, so I only used 0.01 moles. Okay, so I need to figure out how many grams of silver nitrate that actually was. So when you go to the chemical storeroom, silver nitrate is a powder, and you have to weigh it out, measure, and create your solution. So 0.100 moles of silver nitrate, 1 mole of silver nitrate has a mass of 169.87 grams. I got that from the periodic table. You're going to get 16.987. Now, we want to think about what we're limited by. Here there are 3 sig figs. Here there are 4 sig figs. But really, we're very certain about this number. These are things I'm trying to find. We're going to be limited by how accurate my scale is. So the scale I'm using in the lab, can it measure to tenths of grams or hundredths of grams? So you're either going to be measuring out 16.99 or 17.0 grams. So how would I actually make this solution? Flip back in your notes to the previous page. There are 9 steps to making a solution. I had to calculate molarity. Well, I was given that. I had to calculate volume. I was given that. I solved for moles, solved for grams using my molar mass. So that is my writing that I have here. So there is my volume, there's my molarity, here's my solving for moles, here's my calculating grams. And then I actually had to go and get the mass of that solid. So I measured out 17 grams of silver nitrate. I put it in a flask. I filled the flask halfway with water, shook it up, and then added the rest of the water exactly to the 1,000 milliliter or the 1 liter mark. Okay, so that is the end of our notes, and I'm hoping that you have gone back and looked over some of your previous notes to make sure you really understand how we can link solutions and molarity to stoichiometry.